All right, hello everyone. Today we're here to talk about special segments in a circle. Uh, I put 1st of May because the lesson one for this week is due on 30th of April. April comes before May, not August. So we're going to just jump right in. It's a shorter lesson than the first one was this week, so hopefully this won't take us too terribly long, and these problems will hopefully be easy. So let's go. All right. So when two chords intersect inside a circle, each chord is divided into two segments. So you can see that here we've got this piece DS and this piece SB. And then we've also got this piece SA and this piece SC, right? Two segments per chord. And if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So CS, that segment, times AS, the blue segment, is equal to, that is neither of the colors that I was using before, so change that. S, it's closer. B is the pink one, and we're timesing that by this purple. S, D, right? And that is all this theorem means. If this was 2 and this was 3, this could be 1 and 6, and it would work. All right, so make sure you get that down, and then we're going to go on to the next slide for some sample problems. Okay, so these sample problems use the segments of chords theorem. This first one is going to have, we're just looking for the length of this segment. So we set it up. I'm going to use just one color. We know that 8 times 14 should be equal to the 7 times the x. 7 times x. Handy dandy calculator, we know we need to multiply that 8 times 14 to simplify it, and that's 112. 12 equal to 7x, and then we just want to get rid of that 7 that's with our x by dividing. Get rid of that 7, divide, cross it out. 112 divided by 7 is 16. So that segment x is equal to 16. And see, that's pretty simple, right? It does get a little trickier. We're going to use different color and do this one now. So we want to set up, right? We've got 4 and 10 for these two segments. So 4 times 10 is equal to, and then we've got 5 times this 2x minus 8 times 2x minus 8. All right. And we're going to, simplify this to 40. Going to go ahead, and I'm also going to distribute this 5. So 5 times 2x is 10x. And 5 times 8 is 40. Right? So then we've got 40 is 10x minus 40. We got to get the x by itself. So we'll undo, get rid of this 40 that's over here first by adding it. Over to here. Okay. Then we have 80 on the left equal to 10 times x. We divide out that 10 to get x alone. Right, and then x, put it over here, equals 8. But it says we want to find what dw is. and dw is the whole segment, not just the x. So then we're going to take our x equals 8, and we're going to plug that 8 in where the x was, so 2 times 8 minus 8, and I know 2 times 8 is 16. So 16 minus 8, which is also 8, so I guess in this case it would have worked out. So our final answer here is 8, and here was 16. All right, so hopefully those are, pretty simple. It's obviously the second one's a little bit more work, but these are exactly the same type of problems that are going to be on your check-in, so hopefully you're getting it. If you need to pause to finish writing, meet me on the next slide when you're done. Okay. A secant segment is a segment of a secant line that has exactly one endpoint on the circle. A secant segment that lies in the exterior of the circle is called an exterior secant segment. A special relationship exists among secants and external secant segments. Okay, so we want to write all of this down. I know it's kind of a lot, but there's not a lot of writing in this set of notes. So hopefully you can bear with me. Pause it if you need to write this down. So if two secants intersect in the exterior of a circle, so that means outside, then the should say product of the measure of one secant segment and its external secant segment is equal to the product of the measures. I think this should just be regular secant, not secant segment. And its external secant segment is equal to the product of the measures of the other secant and its external secant segment. That's a lot of words, guys. So get that down. I crossed out and changed. That should be a T, not an E. And then pause it if you need. Meet me on the next slide. All right. So this is just a picture to demonstrate. It says here our EA, this guy, times EB, which is the full length of the secant, is equal to EC, which is the external secant segment, times ED, which is the full secant. Right, so that's all it means. We're going to do some examples on the next slide, but this picture might be helpful with the thing that it says. So pause if you're going to write it, because I'm moving on. Okay, so some secant segment theorem problems are right here. Okay, so this first one's the easy kind. Let's do, all right, so we've got 8 times, right, so 8 is the small piece. We need to multiply it by the whole thing, which is x plus 8, and that should equal to 7 times, and I'll just go ahead and write it the same way I did the other, 17 plus 7, even though we could easily do the addition before we do that. So I'm going to go ahead and distribute that 8. 8x plus 64 equals, and I know 17 plus 7 is 24, and then we're going to times that by 7 to get 168. All right, and then we want to get this 64 out of the way, so we'll subtract it to the other side. Okay. 8x equals 104, and okay, good. We're just gonna, our last step, we're just going to divide out that 8. X equals 13. Okay. And then let's look at this other one. This one's going to be pretty tricky because it's got that extra stuff in there. So let's do, I'm going to go ahead and I know 9 and 7 together make 16. So I'll just write it as 9 times 16 this time. And then equal to, it'll be 8 times 8 plus 2x minus 14. All right, we can go ahead and do that 9 times 16 right now. That's 144. Equal to 8 parentheses. I know that this positive 8 with this minus 14 is negative 6. So I'll just simplify that while I'm here. Plus 2x, close parentheses. Then I could either divide out the 8 first, or I could distribute the 8. Since I distributed over here, let's just divide it out first just to see what that looks like. Right? So that means it goes away. 144 divided by 8 is 18. Equals negative 6 plus 2 times x. Got to get rid of this negative 6, so we'll add it. Okay, then we got 24 equals 2x. Divide out that 2, which means x equals 12. All right, and we once again want to find the segment PR. So we want to go back to this guy up here, this 8 plus 2x minus 14, and we want to plug in our 12 where the x was. So 8 plus 2 times 12 minus 14, right? We know this is 24. All right, and then I'm going to just go ahead and put that whole thing in the calculator all at once. Gives me 18 for that piece. So this whole guy is 18. That's about 8. Let me try the 8 again. There we go. That's a bit better. All right, so this guy's 18. That's our answer right there. All right, and hopefully that one pretty straightforward. I think this whole lesson's going to be pretty straightforward. It's setting up the same thing a bunch of different ways. Product equal to product. So hopefully you guys can handle it. If you need help, remember, I'm always there. If you email me or stop into office hours, I'll be there to help. So up next, an equation similar to the one in theorem 10.16 can be used when a secant and a tangent intersect outside a circle. In this case, the tangent segment, or segment of a tangent with one endpoint on the circle, is both the exterior and the whole segment. So instead of having like the exterior part and the whole secant, we have just the one part of the tangent that we use. So it says, if a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. So our next slide's got a picture. Make sure you get down the definition and the theorem. Meet me down on the next slide. So this one's already got a pretty picture drawn for you, courtesy of calcworkshop.com right there. Thank you, calcworkshop.com. So the tangent is EA, right? So we multiply it by itself, which is how we get the EA squared. And then the external secant segment is EC, and the whole secant is ED. So we have EA times EA, or EA squared, is equal to EC times ED. And that's what that one looks like. So we're ready to move to our sample problems now. Make sure you get down your picture in your notes so you see what it looks like. That pesky little blue piece up here keeps coming back. Okay, so finally we have some examples for theorem 10.17. So here we've got our tangent and our secant. We're going to take our tangent squared. So tangent's 18, square it is equal to the external secant segment 12 times the length of the whole secant, which is x plus 12. Right, so we'll distribute, and also I'll go ahead and do 18 squared at the same time. So this is 324. Did not know that one. I had to use the calculator. 12x plus 144. Okay, we want to subtract out that 144. So then we do 324 minus 144 is 180. It's equal to 12x. We got to get x by itself, so we divide out that 12. Pretty sure that's going to be 15. I was right. I didn't say it though, because if I was wrong, it would have been embarrassing. But yes, x is 15. Presto, donezo. All right, we got one last example. Once again, got a more complicated, it's got an expression instead of just an x, but we can still handle it. Start by setting it up with 6 squared equals 4 times, this is going to be 4 plus, it's got to be the whole secant, 2x minus 5. I don't know why that happened. All right, we know 6 squared is 36. 4 times. If we combine our like terms, this 4 minus this 5 is negative 1. So I'm going to say it's 2x minus 1. Again, last time we divided out the 4, so this time let's go ahead and distribute it. Why not? Either way works. 36 is equal to 8x minus 4. We want to plus 4 on both sides. So then 40 equals 8x. Divide 8 out on both sides. X is equal to 5. And this one, we're going to have to plug in that x. So 2 times 5 minus 5. Let's take our next step in this color. 2, 5 minus 5, that's 10. Minus 5 is 5. So 5 is this part of the secant, the internal secant segment. But we need EC, which is the whole secant. So we got to add that 5 with our 4. Luckily, that's pretty easy addition. We probably knew that one when we were in first grade. 4 plus 5 is 9. So our whole secant is 9. And that's it. We're all done. So hopefully this was pretty straightforward and easy. If it's not, remember, email, office hours, whatever it takes. I'm here all the time, still at home, haven't left. All right, see you guys next week.